So this says technology landscape. Well, you know, I had to rack my brains on what I was going to say about the landscape, so I thought I'd put the CableLabs member landscape up, and that would be the end of the landscape content of my talk. Because we're a consortium of cable operators, 60 globally, and representing around about 180 million end users. And what we do is that we do R&D on behalf of these cable operator members, and then as a result of the R&D, we often create specifications that are then implemented across this global industry. So that's enough on cable operator landscape. Some of you might have seen this slide before. This is the reason I'm not going to talk about the landscape, because it's too hard. First thing is to say is that landscape in my industry or telecoms industry usually starts with industry forums that kind of share perspectives on the direction for the industry in terms of technology and sometimes commercial propositions. And these industry forums trigger requirements capture by the industry. So I've got 3 on there: GSMA for mobile, next generation mobile networks, 5G partnership project as just examples of that. And every industry has these associations, by the way, whether it be logistics or healthcare. As a result of requirements, quite often telecoms operators get together and they initiate standards. And so, Rick, I think I've got the MEF on there, so you should be happy to see MEF on there. ETSI, NFV, ONF, Broadband Forum, TM Forum, a whole bunch of those, and of course there's many, many of those. And that's the land in which I've lived as an R&D leader for my very long career. Doing R&D in BT and now in CableLabs, the output of the R&D is almost always some kind of standard, because our industry is built upon standards. But more recently, of course, a lot of what we do is software-oriented, so the emergence of open source is a well-known dynamic within our industry, and indeed over the last couple of years it's become a big deal, hasn't it? Open source has got a lot of attention, and I've been nailed at conferences all over the landscape for the last 3 years saying, Don, isn't what you're doing in standards a waste of time, because open source is going to solve it all for you. And I've resisted the temptation to give up everything and go home. Instead, what I did with a few colleagues, particularly Margaret Kiosi at AT&T and Pradeep Sen at Verizon, I was back in BT, we founded this thing called NFV, which basically said, if the open source guys claim that open source can be made carrier grade, well, let's actually see if that actually will happen. And so we founded this thing called Open Platform for NFV, which is fundamentally an integration project. And the idea is it brings together open source projects and integrates them and creates implementations wholly based on open source. And in fact, CableLabs is a strong contributor to that. And I'll, as I always traditionally do, point out Randy Levensler sitting in row 1, 2, 3, 4. Randy, software architect. If you want to know anything about open source, software architecture, OpenFE, go and talk to Randy. And next to him is Robin in our Curio subsidiary where we do testing. But all of that's no good at all, is it, unless we implement something, because we need to actually go out and use this stuff for real. And so we rely upon vendors to do that. And if they implement things right, then the operators will deploy that. But apart from all of that, none of this is going to work if we don't have the skills needed. So always there's an evolution of skills. And so the first thing that we did, Christos sitting in the front with Orange, Christos took ownership of some academic outreach way back in 2013 and winding up the academics with the idea that they would need to modify their telecommunications courses to bring on people with software skills and networking skills. And pleased to see that 5 years on, there's really good evidence of that happening. And indeed, we've even got PhD students now that are doing PhDs in the realm of NFV, which is quite gratifying. All of that says, well, networks are cool again, really, aren't they? Who thinks that networks are cool again? Who thinks networks aren't cool? You go to the drone conference in London, a bunch of guys in there who thinks drones are cool. We had a confluence of a Broadband World Forum, a conference in the ETSI in London, and the drone conference. And I noticed that the age distribution of the drone conference was somewhere around my grandchildren's age. But that's just another story. So NFV is driving, and this is what I claim at CableLabs, right? I claim that while NFV itself is no longer innovation, although there is innovation in how you use and deploy NFV, itself isn't innovation. It's what you're going to do with it that is the innovation, right? So the faster we get all these boring standards done, the faster we're going to be able to create interoperable solutions that do really cool things. For example, Robert, blockchain. And on there is the word security twice, right? And it's not and I've got this fancy graphic with a hand on a log, which I found on Shutterstock. The idea that security is a very important element of telecommunications has always been front of my mind. But somehow in R&D, security R&D people always get very depressed. They never get the resources to do security R&D because security R&D is seen as a cost, right? Our industry sees security as a cost. It's not an opportunity because if you try and sell a telecommunications service to a consumer and you say, my connection's a lot more secure than others, you're going to get into trouble, right? Because you've got to prove that. So you can't really sell security, so it becomes a kind of cost. But nonetheless, it's actually critical. And when I and others, Christos and Pradeep and Margaret and a few others, conceived this idea of an ETSI NFV forum, the first thing we did was we stood up a security expert group. And who was at the NFV tutorial yesterday afternoon? Yep, the tutorial presenters were definitely there. Thanks, Jeremy, and thank you, Joan. But you would have listened to Alex Ledbetter, and you probably heard Diego Lopez earlier on today talking about security for NFV. The first thing we said was, okay, the attack surface that we're going to create with NFV is going to increase spectacularly. And the last thing we want to do is embark on standards and then find that it all falls into the ground because nobody has thought about security. So the security expert group, which I'm now very proud to say is chaired by CableLabs, my colleague, my much-loved colleague Igor Feinberg chairs that group, and yesterday Alex Ledbetter of BT is vice chair and presented a very good tutorial, actually, on security. So catch that, because you're going to find all of the key things that we talked about, including potentially implications of using blockchain to implement security. But the fact of the matter is that while indeed the attack surface for our networks may increase with NFV, actually the mitigations that you can do actually increase at least as fast. So in fact, I would claim with a reasonable amount of confidence, thanks to people like Igor and Alex, and indeed Diego, with some of the things that are coming out of work on blockchain, that we can make these networks even more secure than historically they've been able to be. This is the bit where those of you here yesterday can go to sleep, because I've got a vision of the network as a data center. And actually, this is built on top of the cable network. And it basically says that the place where you execute components of applications is a place where it's most likely to give you benefit in terms of bandwidth and latency. And I asked the question of the audience yesterday, which of you think that bandwidth is going to reduce over time, demand? Nobody put their hand up. The idea that bandwidth is remains static. In fact, the way that I've always looked at telecommunications investment in access is you invest in an access technology and then that limits the bandwidth for the consumer. So you self-fulfilling story, bandwidth demand will not increase because we set it at 2 megabits, right? So demand can't increase beyond 2 megabits because there is no applications that can be delivered above 2 megabits over a 2 megabits link. So in telecommunications, we've always controlled the demand for bandwidth, right? That's just the way it works. And I made this point to a product manager once in BT, and they kind of said, Don, you're wrong. We never will need more than 2 megabits. So why are you working on fiber? Point here is, though, that the idea that very fast access to very high bandwidth is going to be an absolute given. And I'm very happy to know that the DOCSIS network is best in class, both in terms of access and in terms of latency, but only if you engineer it right. So we in CableLabs are working on this kind of architecture where we will stand up, guess what, edge compute at the edge of the network. But the main point about this slide is the applications that we talk about are not the network applications. The network stuff runs on this platform as a given and has carrier-grade performance and probably is largely static in terms of its configuration, at least in access. But you'll be able to do some cool things like applying machine learning to predict faults and to do things like noise mitigation. But the real cool thing was that once you've got that compute platform inside the head end or inside the central office, then why don't you use that to do cool applications, right? It's pretty obvious. And then what you've done is you've created a business case which is stood not just on network virtualization, but also on applications too. So I contend this is a very important enabler for investment because you can do applications as well as networking. So what technology are we going to need to do that stuff? Well, I've talked about carrier grade. Standards-based, right? So open source is great, but in our industry, standards are mandated for all kinds of different reasons. It's secure by design, and then we roll it out to thousands of edge-optimized data centers. And those of you that caught the Google intent-based presentation this morning would have heard the question that was raised by one of the delegates on how do you do intent-based network configuration if you have thousands of nodes as opposed to about 100 Google data centers, where you control the applications environment, you control the connectivity, and you have no imperatives to interoperate at any layer other than layer 7. So cloud-native applications are coexisting with the networking piece. This is a challenge for Randy, who is a software wizard who thinks networks are boring, but he knows that we have to do networks, and his challenge is going to be, how do I create a platform that's optimized for networking and does really cool things with applications? So that's one of the challenges that we're going to be addressing at CableLabs. And in my last 11 seconds, what are we doing? Virtualization, architecture, and technologies for cable. We're focusing on open standards, open source. We're doing some cost-benefit modeling. And we've got a virtualized access platform R&D program based on our own reference stack, which Randy played a large part in writing. Evaluating security challenges and solutions. We've got a really excellent security team under Mike Glenn with some really stellar wizards there on security. So they'll be contributing, have been contributing to standards on NFV. And then we've got a multi-vendor NFV interop lab, which is open for business. That's Robin Koo. Robin, put your hand up. And that is all based around the ETSI NFV architecture, okay? And then finally, because I said yesterday, this is my favorite picture of all time. There has no reason to be on this slide other than this great picture. Some few points that I made yesterday, and I'm going to make again because they bear repeating, is telecommunications are not enterprise IT environments. So despite Google's fantastic presentation, they are an enterprise IT environment, okay? We are massive scale, we are heavily regulated, and we are critical national infrastructures. Google, I would claim, is not one, although we don't want our Gmail to go down. Service continuity must persist through successive waves of technology. Who's been in telecommunications for at least 20 years? So you know about ATM, you know about ISDN, you know about IP, and all through that, we have to keep the services going, and the service level guarantee does not change. Jitter, Wander, doesn't change. Guess what? You can't migrate a service from ATM to IP without changing the spec. So what do? You build another network and then offer a new set of services, and then you hope at some point you can sunset the others. And that is a very, very difficult game to be in. Network operations evolved over decades, and uniquely to each operator in their environment, right? And work stack priorities depend on regulatory as well as commercial imperatives. Guess what? I think the over-the-top players are beginning to discover that regulations are going to be something they're going to have to deal with as well. Open source needs to adapt to this environment because each operator needs control over their destiny. Timely standards are and will remain critically important. And some priorities. Get the standards done. Joanne, Jeremy, get those standards done, out the door, finished, and then we'll go into maintenance and do cool stuff. And then explore possibilities. But you don't do things in radical transformations in telecommunications. Almost everything is incremental, I'm sorry to say. With that, I'm going to say thank you very much. Sorry, Robert, to be a bit over time.
You're on time, actually. We have time for a couple of questions.
I was hoping to escape without any questions. Eh?
Questions?
Perfect, great.
So it's not a question, more of a comment. I mean, you brought up the security in the networkers. I've heard of, I don't know if they, thank you. Thanks. So there's a concept of chip biometrics where you actually put the security is built into the chip.
and you use what's called physically unclonable functions, or PUFs or PUFs. And I don't know if that's part of, if you think that's going to be part of this whole security ecosystem, you know, with blockchain and this, and I think we're going to have a good secured network in the future.
I don't think it's a magic bullet single solution, is there? I was reading an interesting article yesterday about the Indian identity rollout in India, and it's based on a unique number per individual, right? And the problem with that is that once you've figured out what that number is, you can then clone all of that. I think the best thing I can say about security is that it's a whole lot of different things coming together, isn't it? So it's about somehow identifying who the individual is, where is the individual, what's being accessed, and then what's the asset record, for example, blockchain, that ensures that there's no spoofing of that. And I'm not a security expert, but what I would say is look at that presentation from Alex Ledbetter from yesterday. There won't be anything about biometrics in there, but the philosophy is in there, and then you can map your question to that. So sorry to duck it in that manner.